This video is going to go through the odd problems in your Ideal with Daltons and Stoichiometry packet. If you need help with the even problems, check the answer key, phone a friend, or go to tutoring, because this one's just going to go over all of the odds and how to do them. Okay, number one, a student collects ethane by water displacement. Whenever you see water displacement, like something needs to go off in your head, at a temperature of 15 degrees Celsius, so my T is 15 degrees Celsius, and then I give you the vapor pressure of water is that number, so let's write that down. pH2O is 1.5988 kPa, and the total pressure is 100 kPa. The volume of the gas collected is 245 milliliter. How many moles of ethane are in the bottle? So I'm looking for N, which is my moles. Now when you look at this problem, besides the fact that it's on the Ideal worksheet, there's no second temperature, no second volume, etc. It's the Ideal gas law, which is PV equals nRT. And if I say a gas is collected over water, you have to remember that you're going to have to take, to get the pressure of the gas, which is ethane in this case, you're going to have to take the total pressure and subtract the pressure of the water from it. So you have to remember to subtract those two pressures. So the pressure of my gas equals 100 kPa minus 1.5988 kPa. I can subtract these two numbers from one another because they're the same unit. If this was kPa and this was ATM, I would have to change them to make them the same unit. So the pressure of my gas is 98.4012 kPa. Now I want to use the Ideal gas law, pressure, and I'm looking for N. Pressure has to be an ATM for the Ideal gas law. To go from kPa to ATM, which I'm just going to need more space, that is kPa, you have to divide it by 101.3 kPa. And that equals 0.97 ATM. Now volume has to be in liters. This volume is in milliliters, so you're going to have to divide it by 1,000. That is 0.245 liters. Temperature has to be in Kelvin. Add 273. So that's 288 Kelvin. So let's check. My pressure is in ATM. My volume is in liters. I'm looking for N. I know R. My temperature is in Kelvin. Now I can plug this into the equation. And again, you have to use the pressure of your gas, which is total pressure minus pressure of the water. 0.97 times my volume in liters, 245, equals N, times R, which is always 0821, times my temperature, which is 288. Okay, multiply those. 23765 equals 23.6448. I ran out of room, times N. Now I'm trying to get N by itself, and so I have to divide each side by that 23 number. And I get N equals 0.10 moles of gas. And that's your final answer. Let's jump down to number 3. Number 3 says, how many grams of calcium carbonate will be needed to form 4.29 liters of carbon dioxide. The following reaction takes place at a pressure of 1, temperature of 298 K. So for this problem, if you see something about like a chemical reaction and it's things that you know, like calcium carbonate, unlike ethane, it's nothing about water, displacement, write your chemical equation. So calcium is 2 positive, carbonate is CO3 2 negative. So that is CaCO3. And it says it forms CO2. Now you're kind of expected when you look at that to realize that's a decomposition reaction, because you're supposed to know that carbonates decompose into carbon dioxide and a metal oxide. So plus, and if it's a metal oxide, calciums are metal, so calcium oxide. Calcium is 2 plus, oxygen is 2 minus, so CaO. And then check and make sure this equation is balanced, which it is. So I'm looking for grams of calcium carbonate. Calcium carbonate, I'll make sure on the test that it's very specific, but that is a solid. And we have a volume of CO2, 4.29 liters of CO2. Pressure, 1 atm. Temperature 298 K. Now, when you use the ideal gas law, it has to be about gases. So my N has to be moles of the gas. The gas in this problem is CO2. I know that because carbon dioxide is a gas. You should know that. Also, I told you the volume, 4.29 liters of CO2. And so when I list my variables, my N needs to be moles of CO2. And then on the ideal gas law, I also know R is 0.0821. So list your variables. Let's write the equation. PV equals nRT. You will use the ideal gas law whenever you only have one variable missing. So right now we don't know moles of carbon dioxide, but we know volume, pressure, temperature, and R. So we're only missing N. When you have numbers for every single thing except for one letter, you use the ideal gas law. So we're going to do this first. Pressure is 1, volume is 4.29, moles I don't know, R, my temperature. That is 4.29 equals N times 24.4658. Now to solve for N, divide each side by 24.4658. And now we have N equals 1.43, and remember that is moles of the gas. That is moles of CO2. The question did not ask for moles of CO2. Let's go back. It wanted grams of calcium carbonate. Now that I have moles of CO2, and I'm just going to scratch this out because I'm not doing this problem on here and we need more space. I have a balanced equation. I have my moles of CO2. I'm going to do stoichiometry to change from moles of CO2 to grams of calcium carbonate. 1.43 moles CO2. And I'm trying to go to grams of calcium carbonate. There's not a coefficient in front of either one of these. So 1 mole of CO2 equals 1 mole of CaCO3. And then I want grams of calcium carbonate. So 1 mole CaCO3. And I need to go find the grams of calcium carbonate to put up top. So off to the side, CaCO3. calcium is 40.078. Oxygen 15.999 times 3. Carbon 12.011. Add all of those numbers up together. When I add all of those up, it equals 100.086 grams. So that's the molar mass of calcium carbonate. That is what comes up here. And then that will give me my answer. So 1.43 times 100.086. So my final answer is 143 grams of CaCO3. Next, let's do number 5. Okay. Gases insoluble in water can be purified by bubbling them through water. This process removes impurities that are soluble in water, but at the same time water vapor is picked up by the sample. A sample of nitrogen that was purified by this method had a volume of 6.523 liters, so my volume of nitrogen, 6.523 liters of N2 at 26 degrees Celsius. Temperature 26 degrees Celsius, total pressure 747 torr. So P total 747 torr. In a gas sample saturated with water vapor at 26 degrees Celsius, the pressure of the H2O equals 25.3 torr. How many moles of nitrogen were in the sample? So when you see a problem like this, when you're given total pressure and pressure of the water, you have to remember Dalton's law, which is P total equals the pressure of the gases. So pressure of N2 plus pressure of H2O. So to get my pressure of just N2, I'm going to take my total pressure and subtract the pressure of water from it. So pressure of N2 equals 747 torr minus 25.3 torr. My pressure of N2 equals 721.7 torr. Now, I hope you know that you can't use the ideal gas law with a gas in the unit torr. It has to be an ATM. And so if you don't remember, flip back in your packet, 1 torr, and so I'm going to do this down here because I ran out of room, 721.7 torr. 1 torr equals 1 mmHg. And then there are 760 mmHg in 1 ATM. Okay, and I'm just going to scratch this out, and I'm going to have to do work down here. Whatever. So 721.7 divided by, that is 0.9496 ATM. It's my pressure of nitrogen. So let's check everything out. I want to use the ideal gas law. PV equals nRT. I'm looking for N. My pressure, I have an ATM. My volume is in liters. My temperature needs to be in Kelvin, so add 273 to that number. That's 299 K. I know R, and I'm looking for N. So now I'm good to plug into the equation. Pressure 0.9496 times my volume 6.523 equals N times R times my temperature, and then solve for N. .194 0.2408 equals N times 24.5479. To solve for N, divide each side by 24.5479. We have N equals 0.252 moles of nitrogen. And that is the final answer for number 5. Number 6 is probably going to be another long problem again, so I'm going to scratch that out so I can do my work down here. Okay. Oxygen gas can be generated by heating potassium chlorate to yield oxygen gas and potassium chloride. If 85 grams of potassium chlorate are reacted in a 2.5 liter container and the oxygen gas is cooled to 21 degrees Celsius in the same container, what's the partial pressure of the oxygen gas? Okay, when you read this, there's a lot of stuff going on, but I can see there's a chemical reaction, so let's write that first. So if you heat potassium chlorate, it's going to yield, which means makes, oxygen and potassium chloride. Chlorate is ClO3, 1 negative. Potassium is K positive. So that is KClO3 makes oxygen, which is O2 plus KCl, potassium chloride. Now let's balance this equation. 3 oxygens here, 2 here, so I need to make oxygen 6. Put a 2 in front, a 3, and a 2. Now it's balanced. Okay, I have 85 grams of this. What else did I say? The volume is 2.5 liters. The oxygen gas is cooled to 21 degrees Celsius. And I want to find the pressure of O2. Let's just change temperature really fast because we know that's going to have to be Kelvin. 21 plus 273. 294 K. So I have my balanced equation. Let's think about the ideal gas law. PV equals nRT. I'm looking for pressure of oxygen. I know my volume. N. I don't know N. If I'm looking for pressure of oxygen, N is going to have to be moles of oxygen. Pressure of oxygen, moles of oxygen. They have to be the same thing. Also, oxygen is the gas. For the ideal gas law, I have to use a gas as moles. You can't use moles of a solid, which potassium chlorate is. And then I know what R is, 0.0821. So I am missing P and I'm missing N. You can't do the ideal gas law when you're missing 2 letters. You can't. So instead, I'm going to have to use stoichiometry first. You use stoichiometry first when you have multiple variables, so 2 letters missing. And I gave you a big clue. I gave you 85 grams of this. Now, potassium chlorate is not the gas. Remember, oxygen is the gas. So I need to figure out moles of O2. But I can take my 85 grams of KClO3, because that's how much I have, and change that to moles of O2 using stoichiometry. Okay, so grams of KClO3. So I'm going to start with the amount of grams I have, which is 85 grams. Let's go find the molar mass of KClO3. Looking at my periodic table, added potassium, chlorine, and 3 oxygens. When I add up all of the masses of that, it is 122.548 grams of KClO3 in 1 mole of KClO3. I'm trying to find moles of O2. This is moles of KClO3. So we need to change that to moles of O2. look at my coefficients. It is a 2:3 ratio. Make sure your units completely cancel out. So moles of KClO3, down here will be 2 moles KClO3 to 3 moles of O2. And then I'm going to stop here because when I list my variables, I'm trying to find moles of O2 so I can find the pressure of O2. And so let's figure out what this is. Now, make sure, and I'm going to show you in the calculator how I type it in. You need to multiply everything across the top together. So do parentheses, 85 times 3, close parentheses, and you want to divide it by what's at the bottom. But you need to multiply these two numbers together first. So I'm literally going to type it in like this. Parentheses, 85 times 3, close my parentheses, divided by, open, 122.548 times 2, close. That will multiply these together and multiply these together, then divide the numbers. So the order of operations will be correct. And when I do that, I get 1.04 moles of O2. So now I have my N, 1.04. Now let's come back up to the top. What was I even looking for? I was trying to find the pressure of oxygen. I know I'm going to have to use my ideal gas law. PV equals nRT. Pressure I'm looking for. Volume, 2.5 liters. So P times 2.5 equals N. I now know N. I just solved for it. 1.04 moles of oxygen. My R. And my temperature, which was 294. And now I have P times 2.5 equals 25.102896. So divide each side by 2.5, and we have pressure equals whatever that is. Pressure equals 10.0 atm, and that is the pressure of my oxygen gas. And one more. A sample of nitrogen gas was collected over water at 20 degrees Celsius. T equals 20 degrees Celsius. I hope something in your brain, you should be like, collected over water, collected over water. That means I'm going to have to do the thing with the pressures where you subtract them. And it's collected at a pressure of 1 atm. The volume of the gas is 250 liters. What is the mass of N2 collected? Okay, so I'm looking for mass, which is grams of nitrogen. Let's write that up top. And nitrogen is N2. And then at 20 Celsius, the vapor pressure of water, so the pressure of H2O, is 17.5 torr. Okay. So, I hope in your brain, when you see gas collected over water, you know now that you have the pressure of your gas, so the pressure of my nitrogen equals the total pressure minus the pressure of water. Now my total pressure is 1 atm. My pressure of water is 17.5 torr. You can't subtract things in different units, so let's change torr to atm. It is 1 torr is 1 mmHg, and then 760 mmHg is 1 atm. .023 atm. Okay, so pressure of N2 equals 1 atm minus 0.023 atm. So the pressure of my nitrogen is Okay, so now let me list all this out. PV equals nRT. My pressure of nitrogen is 0.977 atm. My volume, 250 liters. My temperature, 20 Celsius. We know that's going to have to be Kelvin, so that's 293 K. R, 0.0821. So we don't know N. But that is the only letter we're missing, so we can plug this into the ideal gas law. 0.977 times 250 equals N times 0.0821 times my temperature, 293. Multiply those, that's 244.25 equals 24.0553 times N. Now I'm going to have to divide each side by and I get N equals, divided by that 24, 10.15 moles of nitrogen. Now, let's look back. The question didn't ask for moles of nitrogen, it asked for grams of nitrogen. So you're not done yet. We're going to have to change moles of nitrogen to grams of nitrogen. Okay, so 10.15 moles of N2 times 1 mole N2. Make sure you look at nitrogen, and because it's N2, you multiply the mass by 2, is 28.014 grams of N2. And so this would make 284 grams of nitrogen, which is quite a bit. But when I look at my volume, the volume's 250 liters, so yeah, grams should be a lot. Now remember, I only scratched out the even problems because I needed space. You're expected to do the even and the odd problems. If you have trouble with the evens, ask a friend, go to tutoring, check the answer key, but make sure you figure those out.